Okay, let me repeat where we were, right? So we're talking about how to build a parking spot. You guys have just been hired for the Broward County Transportation System. And there's a building here, right? First I asked, tell me your name.
Giovanni.
I asked Giovanni to build a parking spot. So he went like this, right? He lined it up straight. Does it look like a car fits in there?
Yeah.
Right? To scale, right? Not actually, but to scale. So let's say there's a median, there's a building, there's something there that we need the parking to be slanted a little bit. So this line is actually like this. Can the car still park there? No. So then I asked you guys, what do we do? You came in and tell me what you did. Show us. Fix this parking spot that is not working. No cars are going to be able to park there.
Fill in all your missing angles, and then you can answer.
Okay, what did you use to determine when to stop turning that?
I just stopped.
An estimate?
You estimated. So I need you to think about what you're thinking, right? Because you said I just stopped. Could I have kept turning it like this?
Yeah.
Is that accurate?
But it wouldn't be right because like this side, it wouldn't be enough space for cars to park.
Point out what you're talking about.
Okay, like over here, it's
Mhm.
really different from down there, so it wouldn't be equal. It would be like parallel.
Ooh, you use the word equal. What needs to be equal?
The lines need to be equal, so like the same amount of cars can park, and it wouldn't be like too close together.
Can you fix this parking spot?
Exactly.
And guys, there's no wrong or right answers. I need you guys to try it.
Can we make it bigger, or it has to stay the same?
However you want. Just fix it how you think it should be fixed.
I think this should like come out more so it can be a little bit more parallel.
Okay. What do you guys think about how she fixed it? Can the car park there? Yeah? Thumbs up if you think the car can park there. Okay, do you think that's the best use of the space?
So you want us to start
Why not?
whatever is
It depends on like, are there gonna be a lot of people parking there, or just like? for
Ooh, I
small
like how
parking?
you're thinking, right? So now, as working for the Department of Transportation or having people that you work with, businesses, what if it's a place that has a lot of stores, a lot of traffic?
Then the parking space would be a little bit more bigger. It would be small. 'Cause, like, a lot of people are gonna park there.
If there's a lot of people though, traffic, high traffic, lots of stores, lots of people, is there gonna be more cars or less cars? More cars, right? And you can record them a little bit when they're talking. So don't be scared. More cars, right?
Yeah.
So should the parking space be that wide?
No.
Can someone come and make a revision? There's no wrong or right answers. We're gonna keep fixing it and thinking about each choice that we make.
You fix that one.
Okay, how do we know that's a good parking spot now?
Because it'll be
Because like it's not too big and not too small.
Are the lines equally spaced?
Yeah.
How do you know?
and then
how about if you move it over on the tile so it be
Do it.
Do it.
move it over. Just move it.
yeah, you wanna answer the question, that's what you fill in the angles. That's gonna help you answer.
No. This one right here.
Why did you move it like that?
So now we know that it's an equal space.
How do you know it's equal?
Because each tile is like the same, like.
So you use the tiles as your like ruler, measuring stick, right?
Yeah.
So that's interesting. So now they're equally spaced. So if you had to come up with a definition for parallel lines based on what we just explored, what are parallel lines?
Lines that never stop going straight.
Do these stop though?
They don't intersect.
They don't intersect. What makes these not intersect?
Because they're not like two. They're only one straight.
If we could make this keep getting longer and longer, would these two metals ever touch?
No.
But what if I slant this one a little bit?
Then, yeah.
Are the lines touching?
They're not touching.
They're not
because if
touching
they're
now.
going straight, they're gonna be like,
If we make them longer, what's gonna happen?
they're gonna intertwine.
Exactly. Okay, good. So I like how you used the lines in the tile to make the parking lot straight. But when you go to a shopping center, Are all the parking spaces always straight like this?
Some are, well, depends.
Some are slanted. Go ahead.
I feel like not all of them are built the same. Some of them are slanted and like some of them are straight, but it all depends on where you go.
Okay, so now I'm gonna give you another challenge. So this was the first building, right? You guys are at a shopping center, you're building a parking lot. You guys just accomplished your first challenge. You built a parking spot that all the tiles helped you make sure that they're equally spaced. But what if you're at a shopping center that has slanted parking spaces? So watch this. From here to here. We got our first line. My challenge to the group, you guys have to figure out how to put the next line to make sure that the parking spot is correct. Now let's remember the definition. What does parallel lines mean?
They never intersect
Not just that they don't intersect, think about why they don't intersect.
because they're straight.
What makes them straight?
What makes them straight?
What was true about the way you guys put those metals?
They're equal.
How many tiles are from here to here? And down here? Did it change? So parallel lines have to have what?
A constant.
What is that called? How long something is? Starts with a D.
D.
Or an L. Some people use the word L. Length. When you're driving, what is length called?
180, right?
Distance. Everyone say distance.
Distance.
Distance. So, for lines to be parallel, they have to have the same what? Distance from each other. In algebra, in geometry, that's called equidistant. Everyone say equidistant.
Equidistant.
So parallel lines are never intersect and are equidistant. It's not enough to say they don't intersect.
180, right?
You also have to say they're equidistant. So parallel lines never intersect and they're equidistant. Everyone say that.
180.
Let's say it on 3, 2, 1. 3, 2, 1. Parallel lines.
Parallel lines.
We gotta speak. Your brain learns by seeing, doing, speaking. So let's say it together. Parallel lines never intersect and are equidistant.
Equidistant.
Okay. So those metals are equally distant, right? But why was it easy to put them equally distant?
Because we had the tiles.
We use the tiles, right? Okay, but now we have a black line that's slanted. Can we still build a parking spot?
Yeah.
Okay, but now I want you guys to use your minds to figure out where do we put the next black line. I'm gonna give you guys time to think about that as a team. You can use whatever you want.
Right there.
Right there, I'm gonna put it.
Wait, does it matter?